This is your motion test review. So I'm going to go over all the multiple choices and the short answer. So let's take a look. This is the answers for version 1. Version 2 is the same, except the questions were a little more scrambled. So just find your question if you had version 2. First question here starts about an object starting from rest. So if it starts from rest, that means that velocity is 0. And it goes at a rate of 3 meters per second squared. That tells you that's the acceleration. And they tell you a time of t 6 seconds. So they want to know the velocity of the object at the end of this time. So the best formula you're going to use is this one. And when you rewrite it, you're going to get Vf is equal to AT. So it's going to be 6 times 3. And your best answer here is going to be B. This next question, they want to know what's the speed of the object moving in a straight line. And they want to know specifically the speed of the object from 2 to 4 seconds. So what you're going to do is you're going to just do the slope here. So here are your 2 points. Okay, remember that speed or velocity is change in distance over change in time. So this is going to be a change of 20 meters per second over a change of 2 seconds. So you're going to get 10 meters per second. That should be 20 meters, not 20 meters per second. So let me fix that there. And you get 10 meters per second, which is choice C. Question number 3 is about which average classroom door measurement is closest to 1 meter. Okay, a meter, remember, is like your foot to your hip. So the best answer there is going to be width. These questions are always on the region, so make sure you understand them. The next question is all about drawing vectors. So we've done this in class. So if I go 3 blocks south, 4 blocks west, and 3 blocks north, where am I from where I started? Well, I started here, and I ended here. So this would be my displacement, and I am going to be 4 blocks west. In the next question, which is a scalar quantity, so this is just memorization, so you have to memorize these things. Displacement, you know, is a vector. Acceleration, you know, is a vector. Force, I'm going to tell you right now, is a vector. So your best answer is distance, which we knew was a scalar in our lessons. The next question asks about this particular graph. Remember, this is a distance versus time graph. So the slope is your velocity, and since the slope is constant, that means your velocity is constant. So if you have a constant velocity, your accelerations can't be changing. So your best answer here is going to be choice D. Similar to the scalar question before, you know that speed's a scalar, you know mass is a scalar. Work, you don't know if it's a vector or not, but you're asked to find a vector, and you definitely know that displacement's a vector. Next question here talks about a car traveling 20 meters east in 1 second. They want to know what the displacement of the car is. A lot of people thought this was a velocity. That's not what they wanted. They wanted the displacement. So if I go 20 meters east in 1 second, I am just simply 20 meters east. This would have been the velocity. A would have been the velocity if they had asked you that. In the next question here, you have a person who travels 6 meters north, 4 meters east, and 6 meters south. So where are they? In reference to the position, well, they started here, they ended there, so they are going to be 4 meters east. If an object is traveling east with a decreasing speed, so if my object's moving this way, but the speed's going down, that's what the decreasing speed means, well then my acceleration must be going that way, and that's directed to the west. Here I have a runner who completes a 100-meter dash in 10 seconds. So this is my distance, this is my time. I want to know what the speed is, so here's my formula. V is equal to D over T. And I'm going to put in 100 meters over 10 seconds, and I'm going to get 10 meters per second, choice D. This next graph talks about a body moving at a constant, or moving along a straight line. Okay, that means speed and velocity be the same. And if you look here, you have a velocity that's increasing uniformly. So according to the graph, which quantity related to the motion of the body is constant? Well, certainly the speed's not constant, neither is the velocity, neither would the displacement be, so the best answer here is acceleration. Remember that slope here is your acceleration. The next question talks about a plane that has a speed of 600 kilometers per hour. How long would it take the plane to go 120 kilometers? So you're going to use v is equal to d over t. This is my v. This is my d. So to solve for this, I'll work it out down here. You're going to have time is equal to distance over velocity, which would be 120 kilometers over 600 kilometers per hour, and that's going to work out to be choice A. The last question on this page, the speedometer in a car does not measure the car's velocity because velocity is a vector, so we can get rid of choices B and D, and vectors always have directions, so the best answer there is A. This last question, number 25 or number 15, asks about if it takes a car 20 seconds, so that's my time, to go that distance, and it's traveling at a speed of 20 meters per second, then what's the distance? So we have v is equal to d over t, and I want to know d, so that's going to be v times t, which will be 20 meters per second times 20 seconds. Seconds will cancel out, and you're left with 400 meters. Okay, so let's move on to the part 2. This was, you had to draw a vector showing my overall displacement. I started here, I ended here, and you had to label that D. Then you had to estimate that, so I would say the estimate is probably like maybe 0.8 miles, or maybe you said 1.2 kilometers. Didn't really matter, just as long as you weren't in the ballpark. Okay, part 2 is still related to the running. So I ran the race in 51 minutes and 8 seconds. So I have to get all that into seconds. So to do that, I know that there's 60 seconds in every minute. And I ran 51 minutes. So that's going to be 51 times 60, which works out to be 3,060 seconds. And now I have to add on the 8. So I'm going to end up with 3,068 seconds. Now to figure out the speed, remember you have to show a formula. You have to put in your numbers with units. So I'm going to use the 10 kilometers and the 3,068 seconds. And I'm going to get an answer of something like 0.003 kilometers per second. Then if you want to do the bonus, if you want to convert that to meters per second, you simply had to use the following conversion. 1 kilometer is equal to 1,000 meters, and you would have got an answer of roughly 3 meters per second. Make sure that you show the formula, substitution with units, and an answer with units. The next question here asks, would my instantaneous speed always be the same as my average speed? And you had to support your example. So this would be no, and I'm not going to write it out, but certainly at some point I could be slowing down towards the end of the race. I could be running faster at the beginning because I'm excited. There could be hills, there could be runners in my way, so the instantaneous speed is always going to be changing. In part C, you had to get my average velocity, so to do that you had to write the formula. And this has tripped up some people. You wanted to use your displacement from 1B, so I think I said 0.8 miles. So I'm going to say 0.8 miles, but I'm still using the same time. So if I work this out, I end up getting 2.6 times 10 to the negative 4 miles per second. Now you could have had kilometers if you did the estimation in kilometers. I chose to do mine in miles. But again, you had to show a formula, substitution with units, and then an answer with units. This next question, you had to create the graph. It's kind of hard to draw that on here, but the overall shape should have looked kind of like this, where you had points like that. and then you would have drawn a straight line like that, a best fit line. So coming up with a scale, that would have been distance over here, time over here. That was the first point. Getting the points on the graph would have been the next thing. Drawing a line at best fit would have been the next thing. But then using the slope method, well, to do slope, you had to show this, the rise over run. Then you had to use some points. So let's say I use 25 meters minus 5.1 meters over 5 seconds minus 1 second. So I have the units there, and here you would have got roughly about 5 meters per second. Your answer could have been different, but if you, and that would depend on your slope, but you had to show numbers with the units. The best way of doing this, please remember, is that you don't use what I just did. You don't use the points you plotted, which is what I did here, only because it's hard to measure. You would actually pick points along the line. So let's say, here I'll do it in blue. So maybe you would pick this point here, and maybe you would pick that point up here. And then you would do the slope, the rise over run here. All right, so this would be your run, this would be your rise. Okay, this is the last question on the test. So you had to determine the magnitude of the acceleration from 0 to 4 seconds. So to do that, you would just use acceleration delta v over delta t. At 4 seconds, your velocity is 10 meters per second, and at 0 seconds it was 0. And here you have 4 seconds minus 0 seconds. You'll end up with 2.5 meters per second squared. Again, make sure formula, substitution with units, answer with units. You do the same thing for the second part. You did have to show work. You couldn't have just said it was 0. But your change in velocity would have been 10 meters per second minus 10 meters per second over 6 seconds minus 4 seconds. You would have got 0 over 2 seconds. And here you would have got 0 meters per second squared. On the graph above, it says draw a line to show an object moving with a greater acceleration. So that means it's going to have a steeper slope. So if I go back up and take a look at that, so here's my slope for the normal one, so a steeper slope would simply look like this. And some people chose to actually draw that out and do this. That's fine, but you had to just show a line of steeper slope. So that was your test in a nutshell. If you still have any questions, make sure you came and see me, or come see me. Again, though, you guys did a great job, and hopefully this was helpful.